We have that a resistor RL is connected in parallel with a capacitor in the circuit, so we really have like an RCR circuit. This circuit thus becomes loaded as a low-pass filter. So we're given R, C, and our RL. Well, first things first, before we do anything in here, is we need to make our H of S. And so we need to convert this, and we're going to use the voltage divider method. And before we use the voltage divider method, we need to put this in the S domain. So this Z of C, the impedance of this capacitor, is going to be 1 over S times C. And we can see that these two impedances are in parallel with each other. So we're going to have to do the formula for impedances in parallel. We are going to just call this R naught, and we're going to set this equal to 1 over our first impedance, which is the capacitor, and 1 over 1 SC is just going to be SC, and then we're going to add this to 1 over our RL, and then we're going to have our end parenthesis negative 1. And so if we do some math, we're going to get RL is going to be divided by R1 plus SC times our RL. And so this is our R naught, and this V naught is going to be the same voltage over our RL and C because they're in parallel with each other. So we can write plus minus V naught, and that might help us see the voltage divider a little bit clearer. And so from here, let's write out the voltage divider. So we know that we have H of S. And to find H of S, we're going to have V naught over VI, and we need to use the voltage divider again to find this. So we're going to have V naught is equal to the Vin, which is the source voltage, and then we have the resistor, or the impedance of our V naught, over our resistance of our V naught plus the other resistor. So on top, we are going to have the R naught, which we found to be the RL 1 plus SC RL, and then on the bottom we have our R naughts plus our R. Now, we can see that we're going to have a huge equation because this is really RL over 1 plus SC RL for both of these R naughts. And so what we can do is we're going to first divide both sides by VI, so we get V naught over VI, and then we can see that this is going to give us that our H of S. And then we're going to multiply our entire right side by 1 plus SC RL, and then 1 plus SC RL. There should be a C somewhere in there. And then if we do this, we are going to get our H of S is equal to, we have an RL on top, because remember, this R naught is really all of this. And so the 1 plus SCRL cancels out. And then we're going to have an RL here as well, plus a R. And then inside of here we have 1 plus our SC times our RL. And so this is going to be our new equation. We need to simplify this, and we're also going to plug our values in. We know that our RL is 300, so we're going to have 300K. And this is divided by our RL again, which is 300K. And then we have plus 20K, and then all of this inside of here. We can just keep it as variables for now. And we can see here that we can get rid of these zeros for everything. We'll factor out a 10. We'll factor out a K, and then we can divide everything by 2. And in doing this, we are going to get 15 over, and then we're going to add this divided by 2 with this 1. So we're going to get 16 plus, and now we'll put everything in. So we have our S times our 4 times 10 to the negative 9 times our RL, which is 300 times 10 cubed. And so this is the new equation, and we can plug this into a calculator. After we plug this into a calculator, you're going to get this. Now our S needs to be by itself before we convert this into the J omega domain, which we're going to need for this WC. And we also need to simplify it because of this S right here. So what we're going to do is we're going to multiply everything by 1 over 0.0012, and then 1 over 0.0012. Because what we do to the numerator, we got to do to the denominator. And in doing this, we are going to be left with 12,500 divided by 13,333 plus S. And so this is equal to our H of S. And so this is going to be our answer for part A. We're going to plug this in as 12,500, and then in the denominator we have 13,300, sorry. And so that is that for part A. Now, we need to find our omega c. And to find omega c, what we're going to do is we're going to say h j omega is equal to, and we're going to replace all our s's with the j omega. So we're going to have 12,500 divided by 1,300, or 13,300 plus j omega. And so this is the starting point. We're going to say that our omega c is our j omega. So we'll replace these here. But that still won't give us our omega c, because we still have this h omega c equal to all of this plus the omega c on the bottom. So when we're looking for omega c in a problem like this, what we need to do is find the maximum. We've done this in previous problems, so this formula might look a little similar, but we are going to have our h j omega. I've written this as j omega. It could also be written as omega c. And this is equal to our h max divided by the square root of 2. So this is how we would find our omega c. And to find our h max, what we're going to do is we're going to plug in 0 for our omega. So we will have h of 0, and this is our max. And this is equal to 12,500 over 13,300 plus 0. And that means that our h of 0, which is also our max, is equal to 0.94. So that's our max. We're going to plug that in as well as our h omega c. So our h omega c, we have 12,500. We found that in white up top. We have 13,300 plus the omega c, and this is equal to our 0.94 divided by the square root of 2. We need to find our omega c, so we need to do the conversion from rectangular to polar. This was in previous videos, but basically we need to find the magnitude. And the magnitude is equal to the square root of our real number squared plus our imaginary number squared. There is an angle, but we don't need to worry about that right now when we're looking for our omega, because omega is in rads per second, which is magnitude. And so we can look at our formula and say, well, since the left side is in rectangular form, we are going to square root this and then square this, and then do the same thing in the denominator where we square root the whole denominator and then square this and then square this. Just so everything is equal, we're not breaking any rules here. And then this is technically in the rectangular form when we find it, but if we were to convert it, we would see it would still just be 0.94 over the square root of 2, since we don't have an angle or any imaginary number, since we don't have any imaginary number that influences it. So it'll always be itself when we're converting it to the magnitude, which is the polar form. And so we would need to find our omega c. Doing some basic algebra, we would square root the top, obviously, and then square it, so it would be 12,500, multiply it by the inverse of this entire side, so multiply it by the square root of 2 divided by 0.94. We're then going to square it to get rid of this square root, and then we're going to subtract both sides by 13,333 squared, and then we're going to square root that again to get rid of this squared right here. So it's basic algebra, but it is quite a lot. If we do that, we are going to get that our omega c is equal to approximately 13,262. I wrote 6, but that should be 62. So that's our omega c, and when we write it in our answer, we can write it as 13,262. So that is the omega c. Now, we need to examine the transfer function magnitude and phase as the frequency varies. So the first one is we need to find h j of 0, where omega is 0. Well, we've actually done that previously. We've done that right here when we were looking for the max. So the answer here is 0.94. Now, let's look at part D. Part D, we have this h where we have the j omega c. Our omega c is 13,262. We found that right here. And so we need to plug this in to our h j omega. Well, what is our h j omega? We found that earlier. We actually found it right here. This part. This is our h j omega. So we're plugging it into here. We're going to have 12,500 divided by our 13,333 plus, and then we're going to have j 13,262. And now we just need to plug this into a calculator after we convert it to the polar form. Once we convert it to the polar form, we are going to divide the real numbers, and then we are going to subtract the angle, the denominator angle specifically, from the numerator angle. And we're going to use this, and we're also going to use that the angle is equal to tangent -1 over with the imaginary number over the real number. So that is how we would get that. And then we would get 0.664 at an angle of -45 degrees. So the answer here is 0.664 with an angle of -45. Now we're also going to do the same thing for E and F. The only difference here is that we are going to take this that we're given right here, our omega c, because remember, in all of these problems, it's asking us for like 0.2 times omega c, where this one we just have omega c, and then 8 times omega c. So when we do this, we are going to have 0.2 times 13,626. And so the only thing that's changing in here is this part, where we plug this in. And then the same thing for when we have h and then 8 times 13,622. The only thing that's going to be changing is this part, where we plug in the omega. It's the only thing that's changing, and that will change our answer, but our answer is just going to be 0.92 at an angle of -11.25, and then 0.117 at an angle of -83. And these are both plugging it into a calculator after you convert it to the polar form and solving for it. And so that is how you would go about looking at this problem or any problem like this. If you have any questions, you can leave them in the comments below. And if it helped you, you can look at those notes that are below the like button.